In this video, I'm going to discuss multi-step equations whose answers are either infinite solutions or no solution. So most equations that we solve, they're going to be like x equals 4, maybe x equals negative 2, but x actually has a specific value that you solve for. However, that's not the case all the time. Sometimes different things will happen, and in this video I'm going to talk about those different things that might happen. So here we have our first example. And so I'm going to go ahead and solve it just like I normally would. So I'm going to use my distributive property first, and then I'll combine like terms on both sides. Okay, so when I combine like terms, 5m minus 12 equals 5m minus 12. Well, that's a very interesting thing. So let's try to get my variables maybe on one side. So I'll subtract 5m from both sides. But when I do that, they actually cancel on both sides, and I'm left with negative 12 equals negative 12. Well, that's a peculiar thing. So all my variables have canceled, and I'm left with a true statement. Okay, so what that means is that really it doesn't matter what the value for the variable is, it's always going to work out to be a true statement. So the answer then is going to be infinite solutions. So you could look at this and we could say, well, what if the value of m had been, say, 2? Well, 2 times 2 is 4, so 4 plus 2 minus 4 is negative 2, and 3 times negative 2 is a negative 6. So let's jump over here now. So 2 minus 2 is 0, so 5 times 0 is 0, so all we have over there is a minus 2. So 4 plus a negative 6 is a negative 2. Negative 2 equals negative 2. Hey, a true statement. And you'll notice that no matter what value you put in for m, it will always come out to be a true statement. And this happens, again, because all your variables cancel. Like we had 5m on both sides, and we subtracted 5m, it just goes away. So what happens here is that all the variables cancel, and you're left with a true statement. So the answer for this equation is going to be infinite solutions. In our second example, we have another multi-step equation. So let's go ahead and work this out. We'll distribute first and then combine like terms on both sides. So 7n, we have minus n minus 6 when we distribute, equals a negative 6 plus 6n plus 4. Okay, so combine like terms here and then over here. So it looks like 6n minus 6 equals 6n minus 2. Okay, so when we subtract 6n from both sides to get those n's together, they cancel over here from the right. But oh yeah, looks like they cancel from the left as well. And we're left with negative 6 equals negative 2, which is the same thing that happened in the last example, except we were left with a true statement. In this case, it looks like we're left with a false statement. So all the variables canceled out, and we are left with a false statement. So in this case, we're going to say the answer is going to be no solution, because no matter what value we put in for the variable, all the variables canceled out anyway, and we're left with a false statement. So in that previous example, whenever we tried a test value, let's go ahead and try a test value again. Let's say n equals, I don't know, let's say 4 this time. So 7 times 4 is going to be 28 minus 4 plus 6 is 10, so 28 minus 10. And on the right side, 3 times 4 is 12. Negative 3 plus 12 is 9. And then 2 plus my 9 here is 18. So 18 plus 4. So it looks like 18 equals 22. But again, look at that, a false statement. So it does not work again. So in the previous example, all the variables canceled out and we were left with a true statement, which we said infinite solutions. In this example, all the variables cancel out and we're left with a false statement. So it's going to be no solution, because no matter what value we use for the variable, it will never work out and you'll always get a false statement. So before we work this third and final example, let's think about what happened in those first two problems. Well, in the first one, all the variables canceled and you were left with just numbers, and the numbers happened to be the same on the left and the right side, so it was a true statement. In the second example, the same thing happened. All the variables canceled out. You were left with just two numbers. But the two numbers this time were not the same. So the right side and the left side were not the same numbers. So when you're saying they're equal to each other, that was actually a false statement. But remember, in both of those cases, it was the variables that canceled out. Okay, so let's take a look and see what happens here when we solve this one. So just like the last examples, we're going to distribute first. So 4y minus 8 equals negative 3y minus 3 minus 8. So we have 4y minus 11 equals negative 3y minus 11. So I'm going to go ahead and add 3y to both sides so I can get my y's together. So 7y minus 11 equals negative 11. Well, in this case, I'm going to add 11 to both sides. And this time it's the numbers that cancel out. So you're left with 7y. And make sure you put something on the right side over here. The answer is not just like 7y, but it's 7y equals 0. So it's interesting this time the variables didn't cancel out. It was the numbers that canceled out. So we can still continue solving for this and divide both sides by 7 and get y equals 0 divided by 7, which is 0. Okay, so some students have a hard time with this, and they see that all the numbers cancel out, so they want to automatically say like no solution or infinite solutions, because usually that's the lesson they just learned, and they're really eager to write those words down, right? But be careful that if the numbers cancel out, and you're left with a 0, but your variables do not cancel out, you're actually going to be left with like y equals 0 or x equals 0 or whatever variable you have is going to be equal to 0. So be careful of the difference between infinite solutions, no solution, and when your variable equals 0.